So this right here is in multisim, and this is what we're going to build first. Is just one switch, one gate, one light. And if we run a simulation, this is on right here. You can see this leads to the on, which means our light is off. If I switch this to the off, to the 0, ground is 0, so 0 inverts to 1 and my light's on. So that's how it works. It just does the opposite of whatever this is doing. Now, how do we build this? Okay, well, first things first. We're going to go to Tinkercad, and you're going to build this on a real breadboard, but this is the best view I can do where it looks the nicest. So first thing I'm going to do is get me a breadboard out, and then I'm going to need a switch, and we're going to use a button. Now in multisim we have a single pole double throw. This is actually just a simple button, and we're going to have to wire it a little weird. But this is one of the hardest parts. But once you learn how to do this, we're going to be doing this all semester, so it's going to be quite easy after a while for you. We'll definitely need our output, an LED. What else do we need? Oh, we need an inverter. Now, I'm going to have to go to all, and I'm going to type in 7404. And there it is. This is not an LS. This is a 74HC04, but it's fine. It works exactly the same. What does this look like inside? This looks complicated to you, and you've never used one of these really. But what does it look like inside? And it's actually kind of cool. Just look right here. It's actually just six of these inverters. That's why finally you have an answer. That's why when you brought in and you said place component, and you said 74, I need one. That's why I gave you 6 choices, A, B, C, D, E, F. In one integrated circuit, there are 6 different ones, and once you know which one you're going to use. And when I do the AND gates, which is an 08N, right here, it gave me 4 choices. Why only 4 choices for the AND gate? Because in an AND gate, there's only 4 gates, because there's more wires, because they have 2 inputs. So this is what it looks like. Now, the very first thing you're always going to do, always, is whenever you stick one of these in your breadboard, is you're going to power it up. You can see that the notch is to the left, and positive is on the upper left, and negative down here. Okay? So let's do that real quick. I'm going to go here, positive to this row, and this row right here is going to get a negative. Okay? So there we go. That gives power to this. Next thing I'm going to need is a resistor. I'm going to go basic here. And we're going to need one resistor for this button to work, and I'm going to explain how it works. So what I'm going to do is I'm going to drop the resistor in the negative. As you can see, it's in the negative row here. And it's going to this button right here. This right here will be my output. But first, to fix this right, I have to put positive here, and I'll explain how this works. This wire right here, so anything in this row, this is where we're going to get our wire for our switch. That would be this part right here. Oops. Do you guys see this one wire that comes out of our switch right here? This one? That's this right here, anywhere in this row. So I'm going to take this one wire, and I'm going to run it to there, right here, this row. Why am I running it to that row? Because I'm putting it into my inverter right here. Do you guys see this? I'm putting it in there. And that's what I need to do. If you look at multisim, I need it to go from there to my inverter, the input of the inverter. The output of the inverter, as you probably already know, is going to go to a light. So let me do that now. I got lost. There we go. So the output, that's this row right here. How do I know that that's row? Because it's coming out right here. If I go in here to pin 13, then it comes out 12. So here I am. I'm going to come out this row. I can do from here, 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 here. It doesn't matter. So I'm just going to go from here, and I'm going to go to this spot here. Okay. The reason I stopped, I didn't go all the way to the light, is because, of course, I told you before that if you're going to use an LED, we should always use a resistor. This resistor amount should be about 470 or so. It doesn't really matter exactly, 330, whatever. Today we're going to be using 470s, okay? And so here, out of this logic gate comes out to a resistor, then it comes out here, and then I'm going to go to the positive side, so I'm going to have to rotate my light around. It's going to go to the positive side of the LED. The negative side of the LED is just going to go to the negative like that, okay? That's about it, and I think we're actually done. I just want to explain how this button works. So, if I'm not pushing the button right now, then this negative on this row will go through the resistor, a little trickle of it, and will go to this row and go through this wire, and this is a 0. Why is it a 0? Because it leads to ground. So this is a 0 when I'm not pushing it. When I push this button, so when I click this button here, then this, everything on this side, it could be here or here, it doesn't matter, okay? It's this side or this side. So this side will end up flowing over here. So this positive with no resistance overpowers this negative and sends it here, and this becomes a 1. Some of the positive current even comes through the resistor, goes through here, and even gets wasted, just goes back to the ground and gets kind of wasted, but that's why we put a resistor there. So it'll just be a little trickle of waste going this way. And this resistor, how much should it be? I have a 1K here, that'll work fine. A 2K works fine, 2.2K, 2.7K, 5K, 800 ohms, whatever. When I first learned this, I was taught to put a 5K resistor, but I'll be honest, once you start going really high, 5K, 7K, I start to run into problems. But theoretically, you can use up to like a 10K and be okay, a 10,000 ohm resistor. But when you go too high, you actually do run into problems where it's so much resistance that like no ground is flowing through it, or such a little amount, it's not enough for this to work. So this should work fine, but don't forget I need power. This is a digital electronics, so it should be running very close to 5 volts. So for that, I'm going to look for a USB on here. There we go. Look at this. Someone took a USB and cut the wires off of it. See that? That's good, because that's what I want. And I'm going to take this and look at these wires here. What do I have? I have a 5 volt positive, a data. I don't care about the data lines. That's for information. And the ground. Perfect. So I'm going to take this ground and put it here. I'm going to take this positive and put it here. However, I want them to spread out. In other words, all this positive, if I ever need it, I want that positive to go here. I think I did it. And, of course, the ground that goes here to this row right here, I want to go over to this ground over here, so that both the black bars on both sides have ground, both the positives have ground. And it should work now. Let's start the simulation. And it's not working. Do you know how I know it's not working? It's because this light's not on. And I'm not pushing the button, so the light should be on automatically. So I did something wrong. Let's just take a quick glance at this. I got positive going here. I do have the positive here. I got the negative here. And I got input from the button here. Let's see here real quick. What's this resistance? This is a 1K. I do have my light. Oh, wait. Well, no, I did do that right. I put this light to the negative. And this is a 470 ohm. That sounds right. And this is going here. It goes here. It goes here. This is positive. This is negative. Let me just double check. Yeah, that's supposed to be negative. That's supposed to be positive. That's good. And this button should work. We got the negative there. It's going here. It's going into my input. And this one's positive. Let me just do a quick double. Why is it not working? Wait, it is working. Why is it working? I didn't even do it. What did I do? I don't even know what I did. I didn't even do anything and it works now. All right. So, notice that the light's on. When I push the button, the light turns off. So it's doing the opposite. That's because it's being inverted right here in this gate. Right here in this one gate. You're welcome to use any of these gates. You can use the one down here or here, whatever's convenient for you. Just look at the drawing. And how do you find this? You literally just type in 74 LS04, and that will get you there. Just click here, click images, and you can find them. They're all over the place. So here's one right here, a nice pretty one. So just type in the part you're using, and that is it.